We've got a great panel for you all today. If I do say so myself, Jeff Sable is joining us, our Director of Account Management. We've got Jim Vada, as always, CWNE 183, resident CWNE. We've got a fun topic, understanding problems and outlining strategies related to high user density. So before we jump in and hand things off to Jeff, I've got a poll for all of you that we're going to launch here. We're going to see how knowledgeable you are on this topic. So I just launched the poll, and I'll read it for everyone who's a slow reader like me. For a location to be considered high density, how many clients are connected to an AP? Jim, what would you say? Jeff, what would you say from 1 to 10? Where would you rate this one?
This question is right in the heart. It's the heart of what we're talking about today.
Yeah, maybe a 5. I think you could overthink this one, right? If you're thinking about the very highest density designs, but
well, let me share the results, and we're not going to give you guys the answer yet. It's part of Jeff's presentation, so this is a teaser. This is a new format for us. Normally, we just blurt out the answer, but we're not going to do that today. I promised Jeff I wouldn't do that. So it looks like the majority of you say 30 plus. So we'll go with that for now. And Jeff's going to let us know how that does. Jeff, I'm going to share the controls with you. Stop sharing myself. And the floor is yours. Good luck.
Thank you. All right. And sorry for the delay. And here we go. So welcome everyone, and here's the answer, right? By definition from the folks at Cisco Meraki, a location is classified as high density if more than 30 clients are connecting to an AP. And I think if I don't have it up in front of me, Don, but I think that's where the majority or the winning selection of answers was.
That's right.
Correct? Yep. So a bunch of folks already knew that. And, you know, from a data perspective, we can pick a number, call it 30, and then I'll remind everyone from 7 Signal and from our KPI page, just like traffic, you know, sharing too many clients sharing the airwaves can absolutely lead to slowdowns, just like too many cars on the highway can lead to slowdowns as well. So thinking about this from a quantified perspective, the screenshot on the left actually reminds me of a few of our clients. And for those of you who don't know, we've got clients who run arenas, airports, colleges and universities. And if you look at the number of clients connected to the APs, the top portion of the left-hand side, you know, up to about 120, maybe a little bit more than 120. And you can think about that as the common areas where the masses of people are located, right? But on the lower left-hand, lower left-hand rows, you have single digits, right? You've got places that might be offices or places that might, could be a dressing room, for example, or a corridor where a manager may be hanging out, depending upon the venue or type of organization. So this information is easy enough to gather. It's easy enough to quantify, but it's interesting to note the difference between a very high density area and in the same location, something that has just a lot less devices connecting to access points. Right. Moving on. So congestion, you think about lots of devices connecting, and I think congestion is a good criteria to look at. So from a definition perspective, again, looking at numbers, chronically high channel utilization, right? Channel utilization greater than 40%, right? And latency is a symptom of congestion, not congestion causes latency, but latency is part of the story. And going further, retransmissions, right? And if you think about having to send data or send information more than one time, you're increasing the amount of traffic and you're not really getting a lot of benefit. And the issue is, the way protocols and technology works is when frames collide, they'll actually be a little bit hesitant or use a back-off timer, and that back-off timer could increase in the amount of incremental time before they do a retransmission. So you're just compounding congestion, right, by having very crowded areas. And then 802.11 Wi-Fi retries accumulate and fail, you will start to lose packets. You will start to lose data, which is never good. And then obviously a big aspect of congestion measurable is low throughput. Right. Jim, anything you would add on this particular topic?
Well, I think it's, the situation is exactly like you described. It can really kind of spiral and compound where, if activity gets too high, if data rates are low, if retries start to pile up, the situation can get really, really bad really quickly and really result in really poor performance for all clients involved. So
yeah,
definitely something to keep an eye on. Put a little question in the chat too, just asking, what's the max number of clients on an AP people have seen, and a couple answers, well over 100 clients on APs. So you hope most of those clients are idle and just sitting there associated, not doing anything. But if they're not, that kind of death spiral can occur.
It gets a little tough. Yeah, down here, the very last point on this slide is target a 30% or lower retry rate, because for all of these different challenges will cascade and accumulate and cause poor experiences. From a congestion perspective, again, it is relatively easy to define. It's easy enough to quantify, and then you can go ahead and, depending upon what processes and tools you have in place, you can go ahead and specify alerts and alarms and figure out how you want to go ahead and take action based upon what's occurring within your operating environment. Right. Again, the 40% number is a concern around channel utilization being greater than 40%. Right. And here, I just wanted to include a little bit of a snippet right here, and hopefully I increase the size of it large enough that you can see there's points where this particular device actually had great throughput. That's blue. There's points where this device started to slow down, or throughput for this device started to slow down. And then there's a lot of time where this particular device is red. Right? And the reason why I thought this might be interesting is it's a reminder. It isn't necessarily constantly bad or constantly a poor experience. It may be intermittent, but obviously for this device or the user using a device in this situation, it can be incredibly frustrating because it is inconsistent and you don't know what's happening in the background.
Hey, Jeff, it may be useful to tell them where you're pulling, how you're getting these screenshots and what you're using.
Got it. Well, this is a screenshot of a device from within Mobileye. And Don, I just wanted to be careful to make sure we're not, over messaging our products. But this is a screenshot from a particular device within our Mobileye software. Right. Here's a couple of additional screenshots. So we looked a moment ago at throughput or download throughput specifically, but here we can see some airtime utilization. These screens come from our Sapphire Eye software, for those of you familiar with Sapphire Eye. And the takeaway on this particular slide for airtime utilization, it depends what the application is or what the applications are. And from Open Reality, they recommend if it's a voice, like a VoIP call like we're doing right now, you want to have like 50% or less as your threshold for airtime utilization, and data could be as high as 70%. And I wanted to show two contrasting views of data. On the left-hand side, the majority of airtime utilization is about 15%, below 20%. There's a couple of spikes, but nothing that looks terribly problematic. On the right-hand side, there's a range, right? You can see there's APs or service areas that may be down in the 5% range of utilization, which is great. Then you can see there's another burst up around 35%, but there's also a group of samples that are well over 50%, and then there's some spikes that get as high as about 70%. So here, depending upon where an end user may be located, VoIP calls could be tough because there is a group of APs that is at that 50% number, which starts to cause some challenges with voice calling. Right. Latency, again, another symptom related to congestion. And here again, I just wanted to show an example. This is another mobilized screenshot where it's not a consistent problem, but intermittently there will be points in time where a connection is poor, where the experience is poor for an end user or the end user's device. Right? It's not necessarily a continuous situation, although there's many examples I could have pulled and put on here as well, where everything would be in the red forever, all the time. Right? Familiar with VoIP scoring or MOS scoring for VoIP calls? I chose this particular screenshot. Again, this is from a device in our Mobilize software, but I chose this particular screenshot because packet loss doesn't seem to be very high. Jitter doesn't seem to be very high, yet the overall MOS score is pretty low. We want to see MOS scores 3.6 or better. And here's a MOS score that is just in the red for the entire duration. But packet loss seems to be okay. Jitter seems to be okay. Jim, am I interpreting the data correctly in terms of packet and jitter?
Yeah, and voice is, it's extremely sensitive to any, variation in network performance. And in this example, I think it's really the jitter that's a little bit high, 69 milliseconds. Like that to be, I think, around 30 milliseconds or below is what most voice vendors will recommend. So that might be what's driving that MOS score down.
Good point. Good observation. Thanks. Right. And for packet loss, again, looking at all these symptoms related to congestion, high density networks, I wanted to show a couple of contrasting examples. And again, these are a couple of screens from Sapphire Eye, different customers, but real world data. If you look on the left, even though it looks like there's some spikes or peaks, the highest reading is below 0.065%. So it's fairly low packet loss. And if you look on the right, you can see there's a point in time where packet loss is 100%. Now it's a single point in time, but it also looks like that particular AP had packet loss at 90 and some other spikes as well. And if you look at the data on the right-hand side screen, the floor looks to be above that 1% number, right? So this would be a tough environment, I think, to have just reliable, high-quality VoIP calls based on the data that we're able to see right in front of us, right? So that's a challenge because you want to be below 1% for packet loss.
Yeah, and that's ugly too because with voice using UDP, there's no other retry mechanism in play unless the application has its own retry mechanism built in. So if those frames are lost, if those packets are lost, they're just gone forever, and it gets ugly.
Right. And then similarly with jitter, I wanted to show a couple of examples. So Jim, I think the left-hand screen looks pretty good from a jitter measurement. Would you agree?
Couldn't be better.
So that's flat at 0. And then you look on the right-hand side, for the most part, if we want to target 30 milliseconds or less, for the most part, the right-hand side is actually below that number 30, although there are some spikes, there are a few inconsistencies throughout, but there are some spikes over 30 on the right-hand side. So potentially it could be a little bit scratchy or a little bit choppy, right? If you're doing a VoIP call, it may not be the highest quality depending upon which AP you're connected to within that particular customer's environment. right? So these are all measurable. And then from a starting to think about, well, how do we try to resolve these issues? If we've identified we've got some concerns, we're operating this type of environment where we have lots of users or high density, what are some of the ways to maybe resolve or mitigate problems from occurring? So one of them is disabling the legacy data rates, the slower data rates, and that will actually help in a few different ways to speed up the management and some of the overhead that goes along with data moving through Wi-Fi. But just it's obvious as a simple reminder, if you disable lower data rates, you're basically going to cut off legacy devices. So you need to be aware, if you make that decision, that some of the devices in your environment may not be able to connect. Right. The other point that may be helpful is if you do devices moving away from an access point, and I want to say this correctly, will actually drop to a lower data rate to try to maintain distance. And by cutting off the lower data rates from an access point, you're sort of pushing a device to roam or encouraging a device to roam to a nearer access point, presumably at a higher speed. Jim, did I say that okay?
Yeah, that's right. That's right. Yeah, the dynamic rate shifting that clients and APs do is it happens as they start to, as signal strength starts to degrade and the noise floor comes up. And so as a client gets further away, it has a poor signal it's receiving from the AP. And so it will respond by using a lower data rate that has a better likelihood of being received further away.
Yeah, so again, disabling the lower data rates is an opportunity to sort of encourage a device to roam, and by roaming, the assumption is it'll go to a higher data rate at that nearer access point. But here's another item to consider, right? If you move away or eliminate your lowest data rates, the legacy data rates, maybe make the low rate a little bit faster, your probes and beacons are also going to go out at a higher data rate because your basic data rate is now faster. And Jim, I'm going to ask you to confirm, did I articulate that correctly?
Yeah. By disabling those low data rates completely, that means management and control traffic has to use a higher data rate. And we're talking, somewhere probably 12 megabits per second or maybe 24 if this very high density environment. And that speeds up the transmission speed of those frames, which means the overhead they cause, the airtime consumption from those frames is lower. So we claim back some airtime, which can be used for data traffic and other efficiency gains.
Absolutely. So that's a benefit that some folks may not have considered or may not have been aware of. And another good rule of practice is just limit the number of SSIDs being broadcast, especially in a high density area. And
we did trigger the chat room a bit with disabling the low data rates. There's some worries around breaking roaming and other things, but I got a kick out of that.
Yeah, it's something to do with care and understand the environment and how your clients will respond to it. So
absolutely something, all of these have to be considered. These aren't necessarily switches that you just throw left or right, but that's absolutely a consideration to make. And here's one for all of my clients, not just high density customers, but for all of my customers, I always advocate 20 megahertz wide channels. And I know there may be instances where some customers have opportunities with their equipment to take advantage of 40 megahertz wide channels and actually get benefit of that. Rarely can any of my customers truly take advantage of 80 megahertz wide channels, but in general, I always advocate more lanes on the highway, as Eric Kamuli might say, 20 megahertz wide channels. Again, we're trying to solve the problem of high density areas, and 20 megahertz wide channels is probably a best practice to have in place anywhere there's high density. Right. So we spoke a little bit about reducing the lowest data rates, but and again, this isn't something just to slam a switch on, but maybe you want to also start considering reducing the transmitter power from the access points. And again, it's something that you'll test or try out, because that will change the behavior of devices or client devices that are going to be accessing your access points. And in parallel with that, you may want to increase the number of access points into a given area, but make sure you put them on different RF channels. Because, and this may be intuitive for most of us on today's call, if you increase the number of APs, but you're broadcasting on the same channel, you're actually going to decrease capacity or reduce capacity, because you're going to create a lot of problems, right? And also of the mindset of adding additional access points to hopefully add additional capacity from our friends at eTribeca. If you just throw access points without really understanding how they can impact a particular service area or a particular region of your organization, you're throwing money out and you're creating problems. Right. This is just a note that I got from eTribeca.com. They've seen installations where there's like 3 times as many APs that should be installed, and just a whole bunch of cascading problems related to that. Jim, anything you'd add, or is that pretty much a standalone statement?
Yeah, no, I think you nailed it right on the head.
All right. So we spoke about lowering the basic data rates or legacy data rates. We've suggested maybe tweaking power a little bit, maybe adding access points. But there's another arrow in the quiver. It's 2022. We should talk about Wi-Fi 6, right? So Wi-Fi 6 and OFDMA and the ability to do more things simultaneously is a huge opportunity for high density environments. Right. There's higher data rates, and Jim, I believe this is because Wi-Fi 6 will supports 1024 QAM versus 256. Is there something else that contributes to the higher data rates, or is it the modulation?
That's the biggest change. Yeah, the addition of 1024 QAM, which enables MCS 10 and 11. Now there are some other differences that also resulted in some marginal increases in data rate, but this is the biggest change. Yeah.
Yeah. So it's a nice opportunity. This is Wi-Fi 6 that we're talking about. All of us know today there aren't necessarily, 802.11ax devices are not yet the majority, but it is changing. I can tell all of you for a fact. I've got many customers who are starting to have AX devices dominate their Mobileye devices that they're using our Mobileye software on. So everything's changing and moving towards AX. The one question I actually want to throw out to Jim. So we just discussed a little bit about modulation and OFDMA being able to do some simultaneous multi-device communications. What else is out there that is going to contribute to the benefits of Wi-Fi 6? Have I missed anything?
A couple things. One is BSS coloring and how spatial reuse operation and having 2 nav timers on Wi-Fi 6 devices can use that to, in some cases, get a little bit better channel reuse. Now, what we've seen so far from the equipment that's been released is that it's really just access points that support spatial reuse operation and not clients. So it's the APs that are able to transmit over other signals, even when the channel's busy, if there's still acceptable SNR in that case, and not the clients. So marginal differences, but not major differences.
Yeah, but those marginal differences they can add up incrementally. They can add up, and obviously move performance in the right direction for these environments. So we've shared some suggestions and some items to consider. And I'll throw out one last thought. This is from Extreme Networks. Designing for high density can do a lot more to reduce some of the challenges than just upgrading hardware. So, I hope everyone keeps that in mind as you identify some of the root cause problems that are occurring within high density environments. It's the design, not just necessarily buying new devices and new APs, but in conjunction with the best hardware, you want to make sure you've got really good design considerations in place.
Yeah, that's very true. It's still the case today, despite the advances with Wi-Fi 6, that, for example, if you had a very well designed 5 gigahertz 802.11n network, it will dramatically outperform, a poorly designed Wi-Fi 6 network. So makes a huge difference.
Exactly. So I think that pretty much wraps up the items I wanted to share or present as part of today's discussion. So now I'm happy to open up to questions and comments that you folks have.
Yeah, and there's been some questions in the chat and just one in the Q&A panel. I want to invite people to use that Q&A panel so we have these all organized. First question here from SA, who says, how do you think Wi-Fi 6 will impact high density environments / deployments, with Wi-Fi 6 being more scheduled / deterministic than Wi-Fi 5? And, I think the impact, like I mentioned before, is somewhat marginal. One of the goals of 802.11ax, like we saw on the slide, was to increase per user throughput 4 times in high density networks. And I kind of scratched my head thinking about where does that number come from? And my best guess is it actually comes from assuming those clients are able to use 1024 QAM so they can use a higher data rate. But that doesn't happen very often because it needs so much SNR. But also assuming those clients are using wider channels, because 802.11ax also operates in the 6 gigahertz band where you can use 80 and even 160 megahertz in some cases. So it's really kind of a best case scenario where that would happen. And I think in the real world, the real benefits over 802.11ac are pretty small. And, in terms of capacity gains, I think what's probably a more measurable and real gain is going to be in congested networks. It's going to be latency for real-time applications where that scheduling is able to prioritize, the voice and video traffic better, even when channels are extremely busy, to make sure that traffic still gets through with lower latency. But I think in terms of overall network capacity, it's the protocol isn't giving us as much as just the addition of the 6 gigahertz band itself is.
Yeah, that's a nice bump.
And that's everything in the Q&A panel. Just looking at the chat. Question about if hiding or not broadcasting an SSID would save airtime. And that's actually not the case, because even if a SSID, if the name of the SSID is hidden, an AP is still going to send a beacon frame for that SSID every 100 milliseconds or so, and that's still going to consume airtime. no help there, although it does make it a little bit more challenging for your clients and to discover the AP. So generally a bad idea. And yeah, we've had some good discussion in the chat. Love all the participation there. But I think with that, that wraps up the Q&A. Nice job, Jeff.
Thanks.
Great job, Jeff. Can you guys all see my screen, or am I not sharing yet? Probably not sharing yet, but I am now. So we've come to the point where Eric Camuli, our Chief Success Officer, joins us for 7 minutes with 7Signal, where he brings some product feature function capabilities back to today's topic just for a few minutes. Eric, I'm going to stop sharing. The floor is yours.
All right. Thank you. Glad to be here. Great job, Jeff. Thank you, Jim and Don. All right, let's do a little sharing here, shall we? And let's show you what this looks like inside 7Signal. So guys, today you should be able to see that. Give me the thumbs up if you can. All right. Okay, here we go, guys. So this is a high density customer who I wanted to show you kind of what Sapphire Eyes at 7Signal, what they see from their point of view when they're in an arena, when they're in a stadium. And this is really cool. So as you look at the date time range here, it's just kind of like, this is the beginning of the day. And then boom, you can see the event, when the event was at, 7, 8, 9 o'clock, right? 10 o'clock. And this is just really cool how you can see how all of the different service areas, how the airtime utilization just spikes up and then comes down. One of the cool things about Sapphire is that it's measuring what's going on in your environment when the network is empty so that you can baseline, as well as when it fills up and it's full. And this is really important, especially in high density, especially in these arenas and these stadiums. Because if you don't have a good baseline, then how are your fans and your guests going to have a great Wi-Fi experience? The bar has to be at a really good level first and foremost. How do we know? We use 7Signal. All right, so this is airtime utilization. And you can see here, right at about the 40 to 50% level on average here. It doesn't get higher than that. So that indicates a nice, healthy environment, right? If we're not climbing all the way up to the 80s and 90s, that means that we've got a good channel plan and everybody is spread out, lots of lanes on the highway, right? Good stuff, just like Jeff was saying. All right, so now let's go down here. Now this is QBSS channel utilization. Now this is different. 7Signal looks at both. We look at what's coming from the controller, and that's what this is right here. And we're also calculating our own airtime utilization, which is based upon traffic flying through the air. QBSS is going to take into account like some idle clients and stuff like that. So that's why the airtime utilization here that we calculate is always going to be a little bit lower than what we see over here, because we're not taking into account some of those things. The same thing is true with station count. So station count, and Jim was talking about this before, station count from QBSS is taking into account all of those idle clients. And it's really important to see, are there a lot of idle clients or not? Because idle clients not sending a lot of stuff through the air concern us less, right? And let's go down here. This is what 7Signal is calculating. So here you can see that the average per station or the number of clients here is only in 18, 19, 17, 18, 19, whereas up here it's a lot different story. So we're going to be able to give you a picture of what's really going on. All right, so now let's go a little bit further. Okay. Oh, check this out, guys. You're going to like this. Okay, so first we've got probe request channel utilization. So look at this. There are very little clients in the arena, so there's not a whole lot of probe requesting going on. But you can see that when the event starts, how the probe requests spike up. Nevertheless, look at the y-axis, and you'll see that probe request channel as a portion of channel utilization is still only 2 to 3%. But what about all those responses? Remember, when your phone, when you're in the arena, is going to kind of do its little probe, and all those access points can hear. And if they can hear, they're going to reply right back and say, I'm here, connect to me, connect to me. And so that's what this looks like. Yowzer, look at the percentage of utilization from just probe responses. Again, if you don't have a healthy Wi-Fi environment, then this is going to be a huge problem for you. And this is a nice way for us to gauge, okay, do we have good baseline? Yes. What happens when the event begins? You can see the probe response channel utilization really spike up into the 30s here, and then it comes back down after the event is over. Now, this is one of the reasons why it's so important to use some of those controller settings. And Jim, I'm going to turn to you for a second. I think it's like it's the TSOP. What is that setting called where you can actually create like a cutoff? Like if it's not a certain signal strength, then don't respond. Is that right?
Yeah, there's a few different ways to accomplish that. A lot of vendors have some high density, special sauce proprietary features. Probably the most common one is a form of probe response suppression. So an AP, if it doesn't hear a probe request above a certain signal strength threshold, it just won't respond. And in a big open bowl, arena environment, that's really important, because otherwise every single AP on the channel is going to hear that probe response. It was sent at a low data rate. It's open air. It's going to travel forever. And then every AP on the channel is going to respond, and you'd get a disaster like this. So those probe response suppression features are valuable. There's another feature that Cisco has called RX SOP, which is more of like a brick wall. Any signal that's received below a certain threshold will just be discarded and transmitted over, which is, again, helpful in those very high density environments.
Super, super important. Again, we want to be able to look at that percentage, and we want to invoke these features that Jim is describing in order to get that percentage of utilization down just a little bit in order to gain back the airtime that we need in order to have a good experience. Now, speaking of a good experience, the last thing I'd like to show you here is how we are measuring what the experience is in the arena during the event. And so we can do that by looking at ping round trip time all before, and you can see how the round trip time kind of spikes just a little bit. Nevertheless, keeping mindful of the y-axis, still looking pretty good. Now let's go back up here. This is upload throughput. Upload throughput in an arena is absolutely critical because everybody's uploading their photos to Instagram or Snapchat or wherever, right? And so from that manner, you better have good upload throughput. So I really like what this arena has done in setting the bar very high. You can see that when the stadium is empty, you can see we're pushing 130 to 150 megabits per second. So really nice, pipe there, right? And then when the event begins, you can see how it dips down the upload throughput, but it doesn't bottom out. It dips down to a point where we're at about 10, 20, 30 megabits per second, which is still healthy enough in order to do the things that customers need to do in order to have a great experience at the venue. And then the last one, of course, download throughput, so that we can download these awesome photos and videos and whatnot. And the same thing, starting out at a very high bar, the event begins, but going down to about 20 to 30 megabits per second during the event in order to ensure that everybody's having a great experience. So there you have it, guys. Using 7-signal Sapphire Eye strategically placed around the arena in order to ensure a great quality Wi-Fi experience for our guests. So there you have it. Happy to be here with you guys today. And remember, you and me, we can't see or hear Wi-Fi, but 7-signal can. Thanks for joining us.
Eric, great job. As always, Jeff, excellent to have you here. Great work this week. We hope you'll join us again. And we hope all of you will join us next week as we have another edition of our Wi-Fi Best Practice webinar series. Jim, thanks for all the color along the way. Great work. See you all next week. Have a great weekend, everybody. Enjoy the 4th of July for those of you in the U.S.
Thanks, everybody. Nice job, Jeff.
Thanks again, Jim.